All right, CNT120, Chapter 3. We just got done doing kind of the beginning of DNS. I just showed you the Wireshark and me loading hack.edu. Let's keep going. Some of what I showed you is going to help with the stuff they're sharing now on domain names and DNS. So name resolution is the process of discovering the IP address when you know the host name. So, as I just showed you, we tried to load hack.edu. When we tried to do that, the first thing that happened is DNS kicked in the background to get me the IP address for hack.edu, and then it talked to the web server and loaded the web page. So DNS was there to help me get this IP that I did not know. I didn't know that 3054 blah 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 IP address. DNS got that for me so that I could talk to and then load the web page from the web server that's hosting hack.edu. This DNS was developed to do that. This was developed in roughly 1983 ballpark. Now, interesting side note, prior to that, this is a little history tidbit, prior to that, back in 1974, a woman by the name of Elizabeth Feinler, the nickname Jake Feinler, she was hired to run the network operations center, if you will, and internetworking center or something like that, and write a research manual for Arpanet. Well, Arpanet was the predecessor of what we now think of as the internet. This was the first network connecting basically research and military institutes, actually universities and like research institutes around the country. At that point in time, she was basically the host database for Arpanet. She was basically the DNS before DNS existed. So people would call her and say, hey, I'm trying to connect to a server out in Berkeley. What's the address of? She's like, hold on, let me look that up for you. Here's the address. Go ahead. And she was maintaining basically a DNS table prior to DNS existing. Well, it quickly became out of hand with the number of servers and IP addresses and etc. that the DNS system needed to be developed so it could be registering and maintaining on its own. But for quite a few years, she was basically the host table or the DNS table for what was out there and how to get to it. Great little history tidbit, great little person if you're looking for an informative speech or informative paper or something like that. Well, DNS itself is an application layer protocol that's there to, when you request a name, it returns an IP address for you. So given a computer name, it's going to give you the IP address of that, whatever that resource is. We have the namespace, that's the entire collection of computer names and their associated IP addresses. Name servers are literally the DNS servers that are holding the database. And the resolvers are basically my client computer trying to get information from the DNS server, that client piece of my browser that's kicking in to get me the IP address of the server I'm trying to communicate with. There's a number of different types of DNS servers. Primary DNS server, the authoritative DNS server for an organization, so the main DNS server for my company, if you will. I might have a secondary, wise if I have a secondary, backup authority DNS server that's there to help and or act as a backup. So if I look at, I think out here, excuse me, as you'll see here at Hack, there's a number of name servers out there. The details are not there, but you at least recognize that there's a couple of DNS servers there for anybody trying to connect to and get information from. Caching server, access to public DNS data and caches, receives the queries from local clients and works to resolve them. So it's kind of like, hold on, let me get that for you. Hold on, let me get that for you. The forwarding is an optional one. It receives queries from clients, but doesn't necessarily work to resolve them, just kind of maintains the cache from previous queries. So it's like, okay, oh, somebody asked for Formula1.com and here's the address. Okay, I'm going to hold on to that in case somebody asks for it. So it's kind of like a little temporary memory, so you don't have to query for hopefully everything. The DNS structure is organized in a hierarchical structure, where we have root DNS servers and then a top-level domain servers and then ones for the different companies, organizations, different schools scattered around the globe. At the root level, there's a root servers used to locate the top-level domain servers. These are the main ones that are used to say, okay, where is the .edu? Where's the authoritative .edu? Where's the authoritative .com? Well, these root servers I can actually get at IANA. So I'm going to open up my link here for IANA. Here at IANA is the root servers. If I go back to the home page here, there should be root zone management. Here's my root servers. Where did I get that? Back here, I think that was in the... where did I get those? Here's the top-level domain. Where was my... Yep, I'll go back to my save there. My domains, root servers. There we go. Okay. Here's my root servers. These are the main ones for basically locating all the top-level domain authority servers. And as you see, there's some companies and places you recognize in here. These are at basically the top of the hierarchy, top of the tree. And here they are kind of scattered around the country, if you will. The top-level domain servers hold information about authoritative servers. That's what they are there for. So now at the .com level, there's an authoritative server that's like, okay, where are all the .coms? So here would be example .com. So those root servers we looked at first. They're the authority on finding all of these. And then the .com authoritative is there to say, okay, I know where all of these .coms are. And the root zone database is where I find those. So if I go here, I'm going to back out here. I'll go back to IANA. Here is your root zone management. This is where the root servers were. Okay. Actually, I think it's right here. Root zone database. That's where these were, right here. And then my top-level domain, registry of top-level domains. Here they are. Okay, here is all the top-level domains. So if I come down here, I can say, okay, who's the top-level domain authority for .edu? I'll come down here for C, D, and we'll go to E. Come on, you can get in here. EDU is EDUCAUSE. EDUCAUSE is the top-level domain authority for anything .edu. They will have the authoritative list on who is hack.edu, who is pennstate.edu, etc. Oops, I scrolled by there real quick. So if I buy a domain name for, .com, networkingisawesome.com, that is going to get, whether I buy it through GoDaddy, Network Solutions, whatever, that's going to make its way up to the top-level domain authority for .com. So if I take a look here, .com, that's maintained by VeriSign. .edu maintained by EDUCAUSE, .net maintained by VeriSign, .org maintained by Public Interest Registry. Okay, so if I buy a domain name like networkingisawesome.com, that's going to make its way to VeriSign, and VeriSign is going to do the double check to make sure there is no other networkingisawesome.com. If there's not, it's like, okay, you now own it. Doug Brown, here you go. Authoritative servers then would be the authoritative server at hack.edu. So EDUCAUSE is maintaining the list of all EDUs, and then for anything hack.edu related would be the hack DNS server. That would be the authoritative server for hack, and it would be these guys right here, whatever those addresses actually are. Now, the domain name and DNS service or process, if you will, works in this manner. And we kind of saw this. We saw it really abbreviated. But my computer is going to hit a local DNS server, and it's going to work to resolve. It's going to try root server. If it gets it, great. If not, it's going to go to the top-level domain DNS server. Great. The authoritative. So it's going to try a couple until it gets the result you're looking for. So it might go, as we saw, a query and response. Boom, done. Here you go. There are two types of DNS requests, recursive and iterative. The recursive, a query demands a resolution or it can't be found. An iterative is going to try the local server and to query other servers. And it's going to try, but it's not going to demand. It's going to try to find a result for you. Resource records. These are the different files that you encounter in a DNS database. There's the A record, That's the name to address mapping for an IP version 4. Quad A is for IP version 6. CNAME is alternative names, if you have alternative names for it, human names, if you will. Pointer record is used for reverse lookup. So if I have an IP, what's the name? Name server record, authoritative name server for that domain. Here's one for mail exchange, where it's used if I have hacked.edu, if I have DL Brown at hacked.edu, where's the mail exchange, if you will. Service record, host name and port of a computer, FTP or SIP, etc., that sort of thing, and then a text record, any other free-form text that might be helpful in maintaining the database. And then here are some examples that the book has about these different types of records. The most popular DNS server out there, DNS server software out there, is Bind, Berkeley Internet Name Domain. Bind server. That would probably be the most common one you see out there. Microsoft has its own DNS server. It's built into like Active Directory, that sort of thing. But Bind is typically the one that you would find in your networks. All right, last section we will come back. Last podcast we'll come back to some troubleshooting.